Alright, so today we're going to look at the random variables and discrete probability distributions. So the learning intention is the knowledge of random variables and the language of probability distributions. So we'll be successful if we can define what a random variable is and the different types, construct a probability density table and able to use it to calculate probabilities, and know what a list of values are. Okay, so according to our NESO Advanced Glossary, so a random variable is a variable whose possible values and are outcomes of a statistical experiment or a random phenomenon. So usually it's denoted by a capital X. So a variable whose possible values are outcomes of a statistical experiment or a random phenomenon. And there's two different types. There's discrete, where it's going to be a numerical value which can be listed, such as things that can, so numerical value that, such as 1, 2, 3, 4, 1, 2, 3, and 4 that can be listed. Continuous, and this is what we'll be mainly focusing in this syllabus, it's the Year 11 course. And continuous is a numerical value that can take any value along a continuum, such as temperature or measured, anything that can be measured. And this is what we'd mainly do in Year 12. Okay. So, for example, a discrete, so something that a numerical value whose values can be listed is, say, for example, throwing 3 coins and then counting the number of heads. So there could be no heads, yeah. There could be 1 head, like for example here. There could be 2 heads, such as that one, or there could be 3 heads. So that is a variable whose possible values are outcomes, the outcomes of the heads of a statistical experiment, flipping the coin, and it's numeric. So we have 0, 1, 2, or 3 heads. So what I've done is created a table. So the number of heads could be 0, 1, 2, and 3. The probability of getting no heads, tails, is 1 out of 8. The probability of getting 3 heads is obviously 1 out of 8 as well. The probability of getting 1 head is 1, 2, 3 out of 8. And then obviously the other probability of getting 2 heads is another 3 out of 8. Now this needs to add up to 1, because the probability of all of it occurring has to equal to 1. So this density must equal to 1. Usually what we would write is that this is little x, so the values are little x, and the probability of this of x occurring is big X. We can draw it in a table, and you could also draw it as a curve, or we could use a histogram, yeah, to represent the and most likely, most of the time, we would represent it as a histogram. Okay, so the set 0, 1, 2, and 3 that's called the sample space. It's not a uniform sample space because the probabilities are all different. Yeah. The set of all possible outcomes with their corresponding probabilities, that's called the probability distribution. Yeah, so the sample space with the probability distribution. The word of values is usually used for the possible outcomes. So the possible outcomes in this situation are values, and the values are 0, 1, 2, and 3. It's discrete. And another word we need to know is a deterministic experiment is an experiment with 1 possible outcome. Yeah. For example, if I was to throw 3 coins and then count how many coins I have at the end of the throw, well, that's going to be 3, and it's considered a deterministic experiment. Okay, and then that probability density would only have one value, with 1 being the probability. Okay. We consider a list as any finite set of numbers. They can be any whole numbers or integers. They're not really they can go on forever, so they're not really they're not really a finite set, so we call them a countably infinite set. Real numbers in an interval such as 0 to 1 cannot be listed. It's continuous, and would use that in year 12. Okay, so here we have a probability distribution table given, and we can double check that it all adds up to 1. So 0.1 plus 0.2, 0.3, 0.25, 0.05 plus 0.1 is 1. Yep, so must equal to 1. Okay, so if we wanted to figure out the probability of the value being 1, we just have to read off the table, and it's going to be 0.2. Okay. If we want the probability of the values being 2, between 4 and 2 inclusive, equal to, we're going to add all these three numbers. So 0.3 plus 0.25 plus 0.05 is 0.6. Okay. If we're going to have the probability of the value being from 1, including 1, all the way to 4, not including, so we've got 0.2 plus 0.3 plus 0.25. Okay, that's 5, so 0.75. D, the probability of the value being 6. Well, there's no 6 there, so it's going to be 0. The probability of it being less than 2, including 2. So 0.3 plus 0.3 is 0.6. And the probability of the value being less than 4, we just have to add these numbers together. So 3, 6 is 0.85. And that's how you use the discrete probability distribution to calculate probabilities. All right, thank you.